I'm good. Hello everyone, my name is Marcin, and together with me is Sirikti, sitting over there. And we coming from Building Point Scandinavia, and we would like to show you briefly why it is beneficial to use Tekla structure, the 3D software, under the reinforcement design. I think after the ISTAC presentation, it's not really necessary, but I think so because I didn't understand anything. But yeah, still it was a really nice presentation. But I'll try to show you some general scope of using like the Tekla's 3D software. So our agenda for today is start short from the introduction about ourselves, what we're doing and what we're focusing on, for those who don't know us. Then we skip into the Tekla part and a few words at the end of conclusion. So Building Point Scandinavia is a Tekla structure supplier on Scandinavian market, as well as a partner for other structural software like CSI and Idea Statica. Some of you maybe heard about it. So we are not Building Point Scandinavia without a reason, because we are working on Icelandic, Norwegian, Danish, and partly Swedish market in all architectural, engineering, and construction segments. So concrete infrastructure, concrete cast in place and precast, steel, offshore, and also field technology. The three main areas of our activities is software, hardware, and services. So we provide set of software for the construction industry, as I mentioned, as well as compatible with those software hardware like 3D scanners or total stations. And of course services, which includes trainings, implementations, and innovations. And without innovation, we create some extension application for Tekla and Trimble Connect. You've seen it in previous presentation, which solve challenges that are not easy to solve today. Our approach is holistic and focused on delivering completely and seamless workflow from the tender phase through the design, production, delivery, and construction. Modeling in BIM technology is based on 3D model, as you could see, which is a database actually, from which we can generate automatically outputs in form of drawings, reports, other formats, and of course EFC models. So model is a source, and when we're changing something in a model, so it's automatically modified in all the other outputs, so there is no need for doing it repeatedly again and check it. So it saves time and decrease errors. And there is no one software which can do everything, of course. You simply cannot be good at everything. So that's why equally important to us and Trimble is system integration. So users should be able to exchange the same data with different softwares. Yeah, so now let us jump into the Tekla part. And I would like to show today the Tekla when it comes to modeling. And it applies to any kind of elements, but what's the most important, it applies also to reinforcement. You have possibility of creation those elements in 3D, but you also have different degrees of initiation. Depends on your need or your advancement. So we can see there is a manual modeling, which means that you can manually into 3D model editor create the shape of the rebars, exactly which one you need. You can do it all the reinforcement like manually, of course, like that. And it's good, it's intuitive, and it's user friendly. But of course, if you need to do it every time, it will take too much time. So you have something so-called custom components. So it's kind of small application that do this repetitive work for you to make it faster and exclude errors. And if I manage to jump into Tekla so I can show it. Yep, I did it, but now I'll need to. There we are. Okay. So just briefly, I would like to show how it looks. So basically, when we have a model, and we can it won't be a demo. It's just so we can create rebars manually. We have set of a lot of options. I won't do a training now, but that's how it looks, just for those who don't know. So it's kind of user-friendly, really easy, and we create real objects in 3D. That's how we can create any shape we want. We can add hooks and etc., etc. But of course, that will be too long. So there's also so-called custom components. So we have the application. We can do it. All of that for us with one click, if my internet connection is working, of course. No, it doesn't. Okay. Okay, let me restore the internet connection. And come back to this. And that was just a simple demo of how it looks in Tekla, creating the reinforcement. And for some time, we'll come back to the custom components. But what is also important that the 3D software gives you way more possibility than that. So it gives you also possibility to create your own precisely customized components and application and plugins. So if there you cannot find, so if you have something unique, you can go even further. So step forward and create own custom components, or as you can see on ISTAC presentation, you also use the parametric design, which is studying more and more popular to create elements. And all that thanks to Open API, which Tekla gives to the client. So you have set of tools, the interface and methods and objects when you can use creating your own functions and plugins. So that was briefly about the modeling. So now let us skip to the next phase. And as I mentioned, the BIM software in general are like a database where you can filter the information and get the necessary which are required in different places, stages, or machines. And here I mean, of course, the reports, the export to various file formats, production drawing, and EFCs. And under production planning, we can use the reports, of course. You can also see it before, but the reports are also generated automatically, and it might be customized to your needs, so you can only decide which exact information, the length, weight, material, whatever. You can decide to create a template and customize the template. Do it in a text file, Excel file, whatever. But you can also move another step forward and drop the manual analyzing and send this data information directly to the machines. And we could also see it before of the presentations, how it works. So in order to be able to send those information to the machines, those information need to be readable by those machines. And here we coming to this system integration, and Tekla have like the set of formats readable like BVBS formats. So after you model the reinforcement, you can export the BVBS format, which is readable by the bending machines. So we quit the manual bending and all possible errors times. There's also a set of other formats like PXML, UXML, Uni, Eliplan, and etc. Production drawing, I think it's known to all of us. This is like the standard today. We could discuss how automated generating production drawing can be. It's also including after everything we taking from the model. So after we model, we getting the production drawing. Of course, we can set the additional information details and so on, but we won't get into that now. And last but not least, the EFC, which has of course obvious value if it is like geometrical representation of our model with all information actually we want. So there is the set of basic information in EFC models, but of course we can add all the necessary information we want our EFC models have in it. So the other contractors or other people we working in other further stages would have the access to those information. So we, again, when we modeling, we creating information if it's the MME status or production date or whatever it might be. We can decide later during the export to include those information, and the later people have access to this information through the EFC. And that brings us to the third stage, so the construction, which production and construction in case of custom place is the same, is a bit different for precast elements. But here is the perfect example of how we can utilize the EFC and all the information included into. And to that, we have Trimble Connect software and Trimble Connect AR, which you also seen on a really nice slide, the LaceTag, how it works. So there's no need to showing it again, but it's really, really useful tool. And yeah, the Trimble Connect is kind of a tool to visualize, to see the EFC and get all the necessary information. And I would like to also show you live again how it looks. But the thing is that EFC nowadays is kind of standard. It's super popular. Everyone agree about the advantages of using EFCs. So, and they're using on building sites and factories and so on. But this create kind of new challenges. So when I was talking about all the data, the model is about a database. EFC is like the geometrical representation of our model with part of data, but it's still often it's too much data. It might be overwhelming for especially for different different group of people working on different stages. So what is the problem right now? It might be too much information. So we need to filter it and deliver exact amount of data to people who need those. No more, because it's just overwhelming. And we also creating part of solution for that. And if I can again jump into okay. So this is a Trimble Connect if it is the browser version, so it's accessible through all the browser readers. And the thing is that through these EFCs, Trimble Connect, it's connected to Tekla. So the point is that we have always up-to-date model. So no matter if it is like on the production, on the factory, or it's on the site, it's known problem that we're using the production drawing when we create elements, but we cannot be never like sure if this is the last update, especially when the process is like designing going at the same time with construction, which is actually, at least in Norway, it's really popular, this way of building. So the change is coming all the time. So having this kind of connection between the EFC, the model on the site, or the factory, with the model on which the designer still works, it's really important. Because then, like, right away, designers, after they implement some change, they send it to Trimble Connect in form of EFC, and then the people on the site or on the factory always have the most updated elements and details and all the information. This is here we have on the right side, we have example of information which are included. That's also, of course, we can decide it under export. We can filter and sort elements based on all those information. For example, here I have like group of based on MME status, which I assume is known. So the people on the site can easily find the objects with specific concrete MME status. Or on the factory, for example, they try to check it out which element is going to be produced next. And when it comes to overwhelming amount of data, so this is, for example, the part of reinforcement for I guess it was from the bridge. The point is that with every single rebar, it might come too many information, and that's unnecessary for people on the site. So there's created the extension, the label, which group all of elements based on the specific attributes. So in this case, we have position number, the size of the rebars, and the length. And it's automatically go through all the rebars we have in a view and group it. And then we can easily find which rebars from the site where it should be in on the construction. And yeah, so we can just come back to our example. That was the custom component. Now with internet connection, I can show how it looks. We use component and it adjusts reinforcement to our need. And that was these 3 stages, which is I wanted to show you how it all works together, how it is important, how the model is a database for all the other stages and how we can utilize it on different levels. How it's like the work we put during the modeling, we can use later when we plan production, when we produce elements, later on the site, and we can just use it. And we decrease the amount of, we decrease the time, we decrease the errors, because when we can automate something, of course, we reduce the chance to mistakes made by us, which is absolutely normal. And that brings me to the end of my small lecture, and a few words from Sirikti at the end. I'll just need to change. Yeah, I just need to.
Yeah, hi, hello. I'm Sirikti Balslev, and I'm Senior Account Executive at Building Point Scandinavia sales team. And in my role, my focus is on the Danish and the Icelandic market. So please reach out to us during the networking part or later if you're interested in a personal online meeting or a demo with us. Important is that Trimble changed the license structure to online subscription licenses back in 2021, meaning that it has become much easier and less expensive to get started with Tekla structures. We have customers in Iceland, and we come occasionally and visit here. So, yeah. And we're very pleased to be here today, and we thank you for the attention on this presentation. And, yeah, please reach out to us if you have any questions. Thank you.